Well, welcome back to part 13 of upgrading my mini lathe. I took time out to make this boring tool, and you may have seen that in one of the shorts I produced. And the reason I had to do that was because I wanted to have a better chance of producing a good M14 thread in this chuck. Well, in the last episode, I had assumed that the M14 thread would be square and concentric with the body of the chuck, but it wasn't. So when I machined a new register to mate up with the mandrel on the lathe, the register and the M14 thread just didn't line up with each other. So I went ahead and bored out the chuck, fitted a bush from EN8 steel. So it's finally time to bite the bullet and machine out the M14 thread in my new chuck. Before doing that, I produced a drawing so that I knew just how much material I had to play with, and indeed you can see just how close the circlip is to the bore of the chuck as I prepared it for inserting the bush. Here you see the bush in its finished state, but of course the bush was produced as a blank here, inserted in the chuck and then machined in position. So we're ready to join the two parts together. The bush is ready and the chuck is bored out to size. I've left a clearance of 2 thou on the perimeter on both this diameter and that diameter, so we get a good bond between the two. I didn't want to take away too much material, but I wanted to have a sufficient material in the bush to be able to turn the thread and make up the register. So that was a bit of a compromise there, but I think I've got that about right. So we're ready now to bond these two together. Okay, we'll leave that, go and have a cup of tea and come back later. A few words on the design of lathe mandrels, particularly screwed mandrels. Here is my Myford ML7, and you can clearly see a screwed portion on the mandrel, followed by a plain portion and a shoulder. And the question is, why have these three separate features? Well, between any two screw threads, of course, there's normally going to be a small amount of clearance. And that means that your lathe backplate or your faceplate can rock slightly on the thread, like this. And that's the situation I encounter when I screw my lathe chuck up onto the mandrel before it seats home. There is indeed a small amount of clearance. Now, when it's brought up against the face, there still can be a small amount of radial malalignment due to the clearance in the thread, like this. To get around that, the designers have used this location diameter, and that provides radial alignment, and then as the feature is screwed home, it butts up against the shoulder, and that ensures axial alignment, so there's no run out on the face of the chuck or the faceplate. And that's the design that I've opted for. I suspect that you can achieve both radial and axial alignment with high quality threads, but I don't think I can. So the way I'm going to mount the chuck for boring the register and cutting the M14 thread is to turn a stub mandrel in the lathe here, just tidy this up, and then mount the chuck in reverse. If I machine this out, that should mean that when I take this off and mount it on the lathe, for that diameter at least, it should be running concentric. I'm now mounting the chuck on the turned portion of the mandrel, so we know that's running true. And you'll see that I'm actually going to tighten up at all 3 points around the circumference. I used to think it made no difference on the scroll chuck, and that wasn't necessary. But I have found it does make a small difference, and it just provides that extra guarantee that the jaws are going to seat properly on the work. Just going to zero out the clock here, and then we have to negotiate the jaws using the cross slide to bring the clock back onto near the perimeter, and we can see that there is indeed run out there. You may not be able to see it on camera, but that looks to me around about 3 thou of run out on the face of the chuck. Just go back to the starting point and we come back to 0. So we can't do much about that. I'm not primarily concerned about the body of the chuck. What I'm concerned about is the faces of the jaws as they grip the work, that they grip the work concentrically and square with the axis of the lathe. Okay, I'm going to start by just removing this excess material. What we'll do is we'll face this eventually so that the original chuck material there on the boss and our bush just form one surface. So we'll just face that back and we'll do the finishing later. Okay, it's time to open up the hole for the M14 thread. We've got about 100 thou to come off this, so quite a bit to go. Well, I very carefully ground my tool, and I'm using the boring tool which I just made. It was made from silver steel or drill rod, and the reason I did that was to gain rigidity by having something a little bit more rigid than simple mild steel, and it's tapered so that again it increases the rigidity and yet small enough to get into this approximately 1/2 inch hole. So we need to make sure that the tool is set up correctly. So it's a bit fiddly this. I'm using the boss on the chuck here just to align my threading gauge, and we've got the 60-degree angle there, and I've got some white paper underneath, and I'm just making sure that this cutting surface on the left hand side here is aligned with the angle in that V, and you may not be able to see that. Let's zoom in a bit, see if you can. Try and swing this down a bit. Okay, that's lined up, so I'll just lock the tool holder in position. Let's take a closer look at the setup from further away. So you can see I've set the top slide round to advance from the rear of the lathe at half the angle, 30 degrees. Perhaps it's more usual to have the cross slide at this angle, so then you'd be advancing a cut by coming out, traversing out in this direction. The reason I don't do that is because you then have the cutting forces in a different direction to the drag on the saddle, and there's a possibility there that your cutting forces are greater than the drag on the saddle, meaning that it's actually going to push the work forward as it cuts and actually run ahead of the lead in the lead screw. I like to do it this way so that the cutting forces and the natural resistance of the mechanism are all in the same direction, so you know exactly where you are. So I've looked up some tables for this M14 thread, and the diameter, the minor diameter, is 0.509 inches, and I've already turned that to size. That's 12.92 millimeters. The depth of the thread, the internal thread, is 0.54 millimeters. That's 21 thou. And if we resolve that into the angle on the top slide at 30 degrees, that works out at 25 thou. So we'll be advancing the top slide by 25 thou to bring us to full depth of cut. But when we get to about 20, I'm going to start trying the mandrel with a male thread, using that as a test piece, and hopefully we can get a nice fit. Because I'm cutting a metric thread on my imperial lathe, I can't disengage the clasp nut, so I'm just reversing the lathe to bring it back to the start position. Okay, I've just taken one more cut. Again, trying the mandrel. Again, I haven't changed any of the settings. I haven't disconnected the lead screw nut. So, yeah, I think we're there. So, yep, we'll stop there. So now what I need to do is just tidy up the face here and make sure everything's clean, and I'm going to deburr, I'm going to chamfer the inside of the thread. So we'll use the same tool and we'll disconnect the drive there. So we just chamfer this, same angle, 30 degrees. Before I go any further, I need to clean up the chuck. There's a lot of swarf trapped inside there. What I'm going to do is, as I remove each of the jaws, I'm going to put pot marks around the circumference so I can put the jaws back in exactly the same place. There's no other identification on the chuck body, and that will just give me more chance of getting repeatability in the way that it grips the work and hopefully provides concentricity. So we'll do that, and that will also involve removing the circlip on the back to separate this ring with the scroll on it from the body. So let's take a closer look at the completed chuck. You can see the register here. You can just about see the demarcation line between the original material of the chuck and the bush. So that will be part of the register. That will be the face, which provides alignment like this. You can also see the internal diameter, which provide the radial location. You can see the M14 thread. I'm very pleased with that. The surface finish is good. It's a good fit on the mandrel. And as we look around the circumference, you can see here the marks I put in there to identify each of the positions of the jaws. So we've got repeatability. So what we need to do now is take this over to the lathe, reinstall the mandrel, and then machine the register on the mandrel, this diameter here, so that it's a nice tight fit on the internal diameter in the chuck. At the moment, of course, it won't screw up because it's a few thou too big. At the same time, I'll also just skim this face here to make sure everything is finally square. Okay, I've reinstalled the mandrel, relubricated it, and we're ready just to turn this down. I've measured this and it's a touch over 0.825, and the register here is about 0.819. So it's just over 6 thou to be taken off this register. So we'll go ever so carefully and hopefully get a nice fit. Okay, 0.819 should fit. Not quite, because I could be a bit out there on my internal caliper measurement. I'll double check that and then come back and see how much I'm going to take off next time. So we'll test the runout now of the chuck. I've got the same stub arbor that I used in the other lathe. This time, however, I'm going to dispense with this portion because that contains the inaccuracies or potential inaccuracies of the other chuck. So we'll just chuck up on the plain portion. And I'm going to carefully go around the circumference and tighten up at all 3 points to give it the best chance of bedding in properly. I'll try that again. I think part of the issue here is that the work is quite heavy for this little setup, so there's a tendency for the work to drop if it's not supported. So let's just try again. Okay, that's more like what I saw before. Okay, that's around about 1.5 thou. The other question you might have is why I'm doing this under power and not by hand. What I've found is that because there's a small amount of clearance in these bearings and you don't get the hydrostatic effect of the bearing being properly supported until it's actually rotating. So that's why I'm testing this under power but very slowly. And we'll test the run out along the length. Well, it's getting worse, as you can see there, up to about 5 thou at roughly 1/3 of the working length of the lathe. We'll try now with a smaller bar. This time I'm using a 5/8 test bar. I guess this is more the typical size that I would want to chuck up in this little lathe. That 1-inch bar is probably a bit on the large side. Let's try that. So at the headstock end we've got around about 2 thou, and that's progressively opening up to 5. Yeah, not really as good as I'd hoped. That's puzzling to me. One possibility is that as I'm tightening the jaws up, the chuck is actually distorting slightly. Be interested to know if anyone else has had a similar experience with this kind of chuck. Anyway, that's where we've got to. Perhaps for more accurate work I'm going to have to make a little setup with collets if that's what I want to use the lathe for in the future. I purchased this little 0.3 to 4mm tailstock chuck with a JT0 taper and a 0 Morse taper arbor. So I'm set up now for tailstock drilling. I think this stage, should have taken that out earlier. I think this is time to stand back and think about the project. What I'd like to do is use the lathe and see what other limitations there are. Well, for the time being, that concludes this series on the mini lathe. The next project is going to be this Adcock and Shipley mill, which I just purchased. I had to dismantle it to bring it here, and the parts are spread out all over the workshop, really, even behind the camera. So I'm going to be renovating this, putting it back together. It's actually in good condition. I just tested the motor's working all right. Again, if you've enjoyed the video, do give me a thumbs up. Thank you for your support and feedback, and consider subscribing if you've not done so already. Hope to see you soon from Pakistan, probably. Thank you.